Assalamu alaikum wa rahmatullahi wa barakatuh. I hope all you all are well. Our today's topic of discussion is quadratic equations. We already discussed the system of equations. Right? We have already done the differentiation between an equation and an expression. Equations can be classified according to the highest power, which is called the degree of the equation or degree of the polynomial. We have done equations of this type: 2x plus 4 equals to 3. We have done equation of this type as well: 2x plus 3y is equal to 7. And we have done equations of this type as well: 2x square plus 4x minus 5 equals to 0. Such equations are linear equations. These were the basic equations which we have done in our first lesson of equations. These are again linear equations because the highest power of the variable is 1 here and 1 here as well, so as 1 here. So what's the difference between the two equations? Linear equations with two variables. Linear equations with two variables. We have done such equations as well. You can see that the highest power of the variable is 2. Such equations are called quadratic equations. We have done a little bit of solution of the quadratic equations before. We are now going to discuss the solution of the quadratic equation in detail today. Quadratic equations, there are three terms in the quadratic equation: ax square plus bx plus c equals to 0. This first term is called the quadratic term. The second term is called the linear term, and this is the constant term. So for a quadratic equation, this quadratic term has to be there. This quadratic term has to be there. We may have a linear term, or we may not have a linear term. We may have a constant, or we may not have a constant. So quadratic term must be there. So that means the quadratic equations can be of this form as well: ax square plus bx is equal to 0. We can have a quadratic equation of this type as well: ax square plus c equals to 0. And we may have an quadratic equation of this form only: ax square equals to 0. The first two types we have already done in factorization and solution of the equations, basic equations. This type we don't need to solve because the roots of this equation are always 0. The roots of this equation is always 0. So we are not going to obviously solve this, but the first two types we have to solve. The first one is ax square plus bx is equal to 0. For such equations, the very first thing is we can take x as common. We can take x as common and then we can solve. For example, we have an equation like 2x square plus 4x equals to 0. So I can take 2x as common. So we are left with x plus 2 equals to 0. And you can see that the two factors are multiplying, so we can write 2x equals to 0 and x plus 2 equals to 0. Why we have done that? Mathematically, when two numbers are multiplying, x multiplied by y equals to 0. Mathematically, we can say that either the first one is 0 or we can say the second one is 0. That's why the whole result is 0. We can separate the factors and we can say either the first one is 0 or the second one is 0, and we can separate them. So I did here. 2x is equal to 0 and x plus 2 is equal to, so we got the two factors, x is equal to 0 and x equals to minus 2. So for the equation of such type in which the constant term is missing, there is one thing which is important to understand, that is, for such equation one of the roots of equations is 0. Okay, the other root we can find. One of the root must be 0 for such type of equations. Okay. Second type is in which there is no linear term. So of the type ax square plus c equals to 0. So in such case, either if possible we can use the formula a square minus b square is equal to a plus b and a minus b, or we can take the square root. Let's solve an example. 2x square plus let's say 8, I'm taking a simple example, is equal to 0. Wait, minus 8 equals to 0. Now I can shift 8 on that side, that's one option, or I can take, it's better to use the square root thing. So 2x square equals to 8. Now 2 will divide on this side, so x square is equal to 8 divided by 2. So 2 1s are 2, 2 4s are 8. So x square equals to 4. Now we take the square root on both sides, and we know that whenever we take the square root, we have to put the plus minus sign. Why we are putting the plus minus sign? Because when we square plus 2, the answer is 4. When we square minus 2, the answer is 4. So whenever we do the square root of 4, we don't know whether the result is a plus or a minus, so we write both the signs, plus and minus 2. That's why we always write plus and minus with the square roots. Okay, I hope these two types are clear. Any question regarding this? Yes, we did these two methods, common and the square root thing, when we were doing the basic equations after simultaneous, when we have started. So we used we already solved these equations. I'm giving you an example with respect to the quadratic equations, no? Okay. Any other question? Okay, let's move on to the major thing. This is what we have done earlier. We will discuss how can we involve, how many ways we can write the quadratic equation. Take it. Quadratic equation can be of this type: ax square plus bx plus c equals to 0. This form is the standard form. This is the standard form of writing the quadratic equation. And second form is x minus a, x plus a maybe, and x plus b equals to 0. This form is called intercept form. Why we are calling it intercept form? Because we can find the values of the x-intercepts directly from this, or we can say roots of the equation. Okay. Third form is, which is the most important one, is a x minus h whole square plus k equals to 0. This is called vertex form. Why we are calling it vertex form, I will let you know. If I want to convert standard form into the vertex form, I have to use a method which is called completing square method. Right, today we will discuss the computing square method. To go to this form, we just simply factorize. We just, if possible, we just factorize and get this form. We cannot go intercept from intercept form to the vertex form. We cannot convert intercept form into the vertex form. We have to go back to the standard form and then we use computing square method to change it to the vertex form. ठीक है जी? हाँ, yes Alicia, beta, when we have such form, I'm just giving an example. Just look into the example. For example, if we have x plus 4 and x minus 5 equals to 0. I want to convert it into this form. So I cannot do it directly unless I expand the brackets. So we have done the expansion. X multiplied by x is x square. Then x multiplied minus 5 is minus 5x. Then plus 4x. Then minus 20 equals to 0. X square minus x minus 20 is equal to this is the form which I got, the standard form. And now I can use the computing square method to change it to the vertex form. Why we are calling it vertex form? We have done the graphs of the quadratic equation in the topics of graph, right? Just wait, let me draw a graph for you. This is the quadratic graph which I am about to draw. Right, this is the quadratic graph. This quadratic graph have few points which we need to remember. Few important points. One is this y-intercept, sorry, this y-intercept. These are the two x-intercepts, or we are calling it roots of the equation as well. And here is a point. This point is called the stationary point or the turning point, or you may simply call it vertex point. There are different names for this point. This is vertex point. Sometimes we are calling it a stationary point or turning point. The stationary point concept we will discuss in differentiation topic. Okay, so I'm not going into that detail. But why we are calling it vertex point? Ali, how can I find the gradient of this curve at this point? What should I do? We have done this in graph. To find the gradient of the curve. Yes, very good, very good. We have to draw a tangent line will touch the curve only at one point. Okay. Yes, Sakina, can you tell me the gradient of the green line, which is the tangent line? Yes, it is parallel to x-axis. So yes, well done. The gradient of such lines is always equals to 0. So gradient of this line point on the curve is 0. That's why it is called a vertex point. At this point, the behavior of the curve will change. That's why we are calling it vertex point. Okay, that's so coordinates of this vertex points are h and k. The coordinates of the vertex points are h and k. So we cannot find the coordinates of the vertex point directly from the standard form. We have to convert that standard form into the vertex form, and then you can see that a x minus h whole square plus k. You can see that we can directly get the coordinates of h and k, which are the coordinates of the vertex point. Okay, this a will tell me whether the graph is a smiley face. I told you smiley face and sad face, the minimum point curve or the maximum point curve, right? Yes, the parabolic curves we have told you, the U-shaped curve and the upside down U curve. We are calling it smiley face and sad face. I hope you remember. Yeah, this A will tell us whether the curve is a smiley face or a sad face. If the value of A is positive, greater than 0, then we have a smiley face. If the value of A is less than 0, then we have a sad face. Yes. Okay, let's discuss the completing square method. One sum from the completing square. Completing square method means we already know that a plus b whole square is equal to a square plus 2ab plus b square, and a plus a minus b whole square, a square minus 2ab plus b square. So we already know that these two are called perfect square formulas. Perfect square formulas. So we'll try to achieve this form which is given on the right hand side to complete the square so that we can achieve this form. For example, we have x square minus 4x plus 5 equals to 0. I want to change this form into the vertex form. So the very first thing is x square minus 4x. Forget about 5. There is no 5 in this question. Assume for a minute there is no 5 in the question. Right? Now we can compare this x square minus 4x with a square minus 2ab. I can see that the value of a is x, right? So the value of a is x as well. This is 2, but this is 4. So can I compare 2b equals to 4, right? And I can find the value of b just simply dividing 4 by 2, which is 2, right? If I add b square here, it becomes a perfect square, a square plus 2ab plus b square. So I found the value of b, which is 2. So I'm adding 2 square, and obviously if I'm including something in the equation from myself, I have to subtract it as well to make the equation balance, right? So this makes the equation a perfect square. This x, this minus sign, this 2 whole square, and then minus 2 is remaining, so minus 4 plus 5 equals to 0. So x minus 2 whole square minus 4 plus 5 is plus 1 equals to 0. This is the vertex form I got of this standard form, right? This is the vertex form I got by using the completing square method. Let me give you one more example of this, then we'll stop this discussion for today. We will discuss a few more things in the next class, and then we'll practice about this. Let's suppose we have x square minus 3x plus 7 equals to 0. I want to change it. The first step is shift this 7 on the side. Now we can compare this, a square minus 2ab. So value of a is x, and 2b equals to 3. So the value of b is 3 over 2. So that means to make it a perfect square, I have to add b square here. So make it a perfect square, a plus b whole square. So I have to add b square here. That means 3 over 2 square minus 3 over 2 square. So this will be x minus 3 over 2 whole square minus 9 over 4 plus 7 is equal to 0. X minus 3 over 2 whole square, 4 is LCM, 4 7 the 28, so minus 9 plus 28 equals to 0, and x minus 3 over 2 whole square minus 9 plus 28 is 19, so plus 19 over 4. This is the vertex form of this. I will give you few practice questions of this, and we will continue the next class, inshallah. Is there any question? You can ask me the question. Yeah, it's simple. We have discussed completing a square a little bit before. It's just a continuation of the same thing. Yes. Hmm. Well done, well done, well done. That's good. That's good. Okay. Thank you. Jazakallah. Take care. Allah Hafiz.